I'm Kim Wilkins, and I'm the founder of Tech Girls, and I used to teach computer science K-8 at St. Anne's Belfield School, and I'm super excited that we have so many educators here wanting to incorporate CS into their teaching.
I'll go next. Hi, I'm Kayla Somerville. I'm the Executive Director of C4K, and I'm super excited because the STEM field is not equally represented by women and minorities, and I'm super excited that you guys are getting people as young as elementary school interested and engaged in STEM. So thank you very much and have fun.
Hey everyone, Nigel here. I'm the Director of Science, Engineering, and STEM at Charlottesville City Schools. And I'm super pumped to work with you this summer and learn more about computer science and the importance of it and how we can teach our students to navigate the computer science world together.
Hi everyone, I'm Jenny Chu. I'm an associate professor of STEM education at the School of Education and Human Development at UVA. I used to be an engineer at Hewlett-Packard and a math and science teacher, and now I'm really interested in helping people teach and integrate computer science in specifically in science and engineering, but across the board as a way to provide more equitable experiences for all students. So can't wait to learn from everyone.
Hi, I'm Luther Tykonovich. I teach computer science at the University of Virginia with a specialty in pedagogy and diversity issues. And I'm excited to share some of the things I know with you and help expand the group of people sharing this important topic.
All right. Zach Minster, how you doing?
What's up, everybody? My name is Zach.
I'm Kim.
I teach computer science at St. Anne's Belfield Upper School.
And I did teach computer science K-8 and founder of Tech Girls, and I'll be starting EDD program at UVA in the fall. So welcome to the CS Institute. This is not what we envisioned how it would be, but I think we're pretty excited. Should we get right to it?
Yeah, let's do it.
All right. We want to thank a bunch of folks. We have sponsors, obviously St. Anne's Belfield School. One of our new partners is Charlottesville City Schools, so some of the educators here are from there, so welcome. And we also have UVA Curry School of Education and the CS department very involved with this experience. So thanks to all of them. So this is our third CS Institute, and we've always had the same mission. We want to demystify computer science. We want to build a regional computer science education community because we know what it's like to be the only one doing computer science in our building, and we want to support you. And then most of all, we want to increase access for computer science for all students. So this week, the theme is all about, so why computer science? Sort of what's the big deal? And we're going to start by watching some video clips. We also, the same time this is running, we're running something called Summer Spark. Do you want to talk a little bit about that Zach?
So Summer Spark is a 3-week program, totally free, accessible to students anywhere they can access the internet. And it's going to be run entirely by students. So they've been creating promotional material and lesson content for students with anywhere from no experience all the way up through a ton of experience to kind of modulate their own summer camp-like experience.
Yeah, we have over 100 students signed up, and I think this is has always been our dream for our student-driven learning, is that they actually start driving it, and it's just amazing. So anyway, I took some video clips because they've all done some spotlights to get the new campers to get to know them. So let's just take a quick peek at this.
What gets me most excited about computer science? Satisfaction once you complete something, especially once you hit that play button or the run button and it all works. And it's really exciting, along with the happiness you get from collaborating with peers, because it's always exciting to have something work out with a peer alongside.
The thing that makes me the most excited about CS would probably be first getting the problem and then just spending time just sitting with it, trying to figure it out. And then once things start coming together, that's when it's really exciting for me.
And what excites me most about computer science is turning a single idea or concept into a fully functioning program and just getting that satisfaction once it's completed.
And one of the reasons why I love CS is the versatility of it. You can make pretty much whatever you want and whatever you can imagine. But not only that, you get to do it with people. It's the collaborative part that also brings all of us together, and that's truly an amazing part of CS.
I really love computer science because it offers so many opportunities to do a lot of fun stuff and make really innovative things.
And I think what gets me most excited about computer science is that there's never one correct answer, that there's so many different interpretations and ways that a problem can be solved.
One of the things I love about computer science is the limitless applications it has to the world around us. I can apply it to my studies in science, math, humanities, and even the arts. I also love the power that comes with being a creator of technology rather than just a consumer of it.
That just makes my heart so happy.
And they covered it better than we could.
Yeah, so I highlighted some of the things. So one of the things for Zach and I about computer science, and I think one of the reasons we love it, is when it can be student-focused and student-driven, it is so powerful for both them and us.
And it's almost effortless in that respect. Bringing the students in is virtually part and parcel to doing the teaching. So it's kind of just an integrated component in the kind of core pedagogy.
Right, and this can be K through 12. This is just not, you know, I experienced that as well in the K-8 space. In fact, one of the people who spoke, Brahanu, by the time he was late middle school, he was teaching me stuff. Like he had totally surpassed me and was holding, you know, his own classes in the CS lab, and that's just amazing to me. So here's some of the things that I heard. You know, this idea that they have a power of being a tech creator. Oh, I can't see what it says because my thing is covering it. What does it say?
That's problem solving.
Yes.
Which I think is like is kind of goes along with being a tech creator. I've seen so many students apply what they have learned in computer science in other areas that it's almost more common than not at this point that students are able to solve a problem in a different discipline using the skills and tool set, the problem solving kind of core tool set that they've developed in computer science.
Giving them choice within design constraints is so important. Yeah, they get to make cool, innovative things. They're already on this technology, giving them the power to create with it. It's amazing.
There's a lot of things kind of circling around agency here.
Yes. And I think this one, you know, there's so many misconceptions about CS, and to hear so many of those kids, like this is a favorite part of it, is this collaboration. I love this one, right? Not just one way to do things, because I think oftentimes when we present students with a problem, it may have already actually been solved. And so they think there's only this one way to solve it. Where with computer science, when you're creating something, that problem has not been solved yet.
I'm just thinking back to the experiences I've had over the last couple weeks, just moving online. Students adapted really quickly to, we're going to make projects that assist us with this transition, this sudden transition to virtual learning. Just building like organizational tools, like there's so many, they were trying to build little applications that replaced parts of the school year that were removed, like traditions, and there's just so many things that they can do with that agency.
So, but there's definitely problems in computer science education, and we're going to cover a couple of them. This one is near and dear to my heart because the number of women in computer science is still really low, whether they're studying it or whether they're in the tech field. You can see there's just a huge difference from the number of men that have been studying it and the number of everybody else, which is way down there. And so there's definitely some issues there that we need to figure out. And then obviously there's also a very big racial diversity problem in tech. And so these, it's only been recently that the tech companies have been willing to even track or release these numbers. And since they've been doing so, they really haven't changed a whole lot. So there's these problems, and yet, every company is now a software company. There isn't, I just can't even think of a company that doesn't have to deal with software in some form or fashion. We had a presentation from Pamela Norris, who's at the engineering school at UVA, And this was to women in tech. And, you know, this is from 2004, but they did this study with a diverse groups of problem solvers, and then like high ability problem solvers. And the diverse groups outperformed the high ability groups all the time, consistently. So, you know, I know that sometimes there's excuses made about the lack of diversity because there's not enough candidates or they don't have the right qualifications. And, you know, we can't be looking for unicorns when if we had diverse mindsets and backgrounds and everything in the room, we'd be able to solve these problems. So we like to reframe CS. One of the exercises we actually went through this last year at St. Anne's was a backward design process where you come up with the essential question and the enduring understanding. And this was actually really helpful. First of all, I had never heard of backward design before. And I thought, oh no, what is this? And it turns out I was actually already doing it. I'm sure you kind of felt the same way. Is that right?
Mm-hmm.
Yeah.
Absolutely.
Yeah, but it was a good exercise to go through. And especially during distance learning, when we really had to focus on what is the most important thing we want to get across to kids related to computer science, this was very helpful. So these are the ones that I think they're applicable K-12, but these are the ones, these first two are the ones that I focus on with K-4. So how do humans and computers interact? And there's just so many different ways, right? It's not just typing things. It's playing with robots. It's doing artwork. It's learning math. It's playing games. You name it, you can do it. And then what is coding? And before I get into that, do you want to talk a little bit about computer science versus coding?
I was actually gonna, like, in the last bit, it does a nice job of emphasizing that the computer is not the object of study. It is the extender of our human capabilities, but it is a computing platform, but it is in no way the thing that we are after.
Right.
So it is not like technology consumption. It is not Excel. It is much, much, much broader. It is more mathematical in nature. So coding is one of those terms that I almost feel like we've been up against it for a number of years.
Yep.
Where there's this big push from a bunch of different, usually corporate sources, to get coding into K-12. And coding or programming is just another way of instructing or talking to a computer. There are an infinite number of programming languages, and none of them are correct or the right choice. It is just a way to express a solution to a problem in a structured manner, and it is in no way equivalent or even really the majority of what we do in computer science. So we study the problems and we study the way that humans solve them, and coding is almost like you could see that as the proof at the end, the paper that you write at the end to demonstrate your findings. Right. More so than it is the be all and end all or the focus of everything that we do. And I think there's this tendency to, when you picture computer science in your mind, to picture somebody banging away at keys. And that is absolutely not what it is. I'd say the vast majority of the teaching that we do is away from screens, and is away from coding as a be all and end all. And I think a long time ago I said computer science is not a set of things that you memorize. It's not a set of magic codes. And I've been using that ever since. It's not a set of magic codes that you memorize and then you're done with and you move on to the next thing. Right. It's a thought process.
Yeah.
More so than anything else.
It's still important as an essential question to understand, okay, what does coding actually mean, right? And it's a way to solve problems and create technology, and it can be done in lots of different ways, whether, especially in K4, there's a lot of problem-solving apps that help you learn computer science concepts like conditions and loops and sequences and stuff like that. It could be creating art. It could be telling a story. It could be sharing what you learned in one subject area by creating tech. That's how you use coding.
A lot of people are actually exposed to coding now through things like home automation and like if this then that, where they're like, oh, if my car pulls up in the driveway, turn my back light on, that's coding. Like that's somebody who's already written a program.
Yep.
Just in a very user-friendly language.
Yep. And then these next two are more middle schoolish. So, what is computer science? It's not the study of technology, right? It's focusing on understanding why technology works and how to create it. And I think that's a big thing that often gets convoluted, right? That it's all about technology, and no, it's all about learning how that technology works and making it do things to solve your problems. This one is a big part of it. We feel that computer science has an impact on everybody's lives, and that's why we feel like every student needs to have some exposure and familiarity with it, because otherwise they're not going to know, like, these decisions that have already been coded, how that impacts you.
It's
right?
very difficult to contextualize the things that are happening in the world without understanding the way that that technology is built. I see a lot now about how AI reflects the biases of its creator.
Yep.
So when we think about facial recognition technology, when we think about the things that are sort of billed as a panacea to society's problems, we have to understand that those pieces of technology alone are not going to solve them.
Yeah. Yeah, and I'm glad to hear. I feel like that is being more acknowledged before. I feel like when I started in the field, technology is neutral. I'm like, oh, that can't be right.
It is just a mirror image of its creator.
All right, so here are our goals for you. We obviously want you to learn. We hopefully want you to collaborate. We're providing some opportunities through office hours, and we can help get you connected as well. And obviously, we want you to be creating. We want you to be stepping outside of your comfort zone. You're going to be trying things you've never tried before, and that means you're going to fail. So we need to embrace failure. And actually, this is a big thing we talk about all the time with all ages of kids.
And adults.
Yes. Because if you're doing computer science, by the very nature of computer science, you're going to be failing. And there's a great video that Dr. Luther Tykhanovich has created for you to learn a little bit more about that. We hope that you're going to learn about and get hands-on with at least a couple of CS integration lessons and projects across whatever subject area you're interested in, and you're going to remix at least 2 of those lessons so you're ready to use them in your classroom in the coming year. And then obviously we want to connect and build this community of practice. So this is the week's overview. This week is why should I teach computer science? And then we go into some CS teaching strategies, strategies to increase equity in CS, because we've already seen there's a ton of problems with the current state of affairs. And finally, last week to sort of extend and plan and get that sort of, those lessons ready for your environment. And we've sort of laid it out in 4 steps there. And so these are really do at your own pace kind of activities. There's going to be a learn activity, learn things where there might be videos or readings or things like that to learn more about the theme of the week. And then there's do, where you're going to get hands-on with CS through lessons or video tutorials. And then we are going to be holding a couple of office hours that are optional. You don't have to show up, but we hope you do. If you have questions, you need moral support, you want to connect with others, those are available for you. Plus, they'll include more of the team that's been planning this institute. And then finally on Friday, we're going to have a Zoom call where we hope that folks will kind of show and tell the things that they've been doing over the week. And then finally, there'll be a opportunity to reflect. And we're using, for some of you, we're using Padlet for that so that we can see each other's, what we've been going through the week. So your landing page is going to look like this, and let's see if I can go there. And then these links will be live once it's ready. You're going to get an email with the Zoom links because we don't want to make those public. Everything we're sharing is going to be available after this time as well. So that's why we want to have these links live. So week 1, we're recording this a little bit early, so some of this may change a little bit. But we really want you to complete the pre-survey. That would be very helpful to us. There's a Padlet to introduce yourself, so do that. This will have the video that we're recording right now. And then, like I said, there's these learn activities. We have lots of resources in case you want to really take a deeper dive. This week, you're going to do unplugged activity and then do a CS lesson as a student. Come to office hours and show and tell, and then here's a place to do reflection. And the final thing is, so where is everything? Now, what I was showing was the CS Institute's folks landing page. There are a group of you from Charlottesville City Schools, and you're going to be using a Canvas, which you should have a link to. We're hoping, even though there's sort of 2 tracks going along, that you'll be able to interact with each other, especially during those office hours and show and tells. And if you have questions, let us know at Spark. Any other thoughts you want to share before we wish them well?
I think the first hour is the hardest if you're brand new to it. But just like I would say to a group of new students, once you push through that first hour, it's awesome.
Yeah. Yeah, those aha moments are great, but it takes a little work to get there.
Yep. And even though we are at a distance, we're here for you.
Yeah, for sure. So even if you just have questions about whatever and you're not able to come to an office hour, please do send us something at Spark. All right. Good luck. We look forward to seeing you.